Hi everybody. Today we're going to go over the topic 6.5 notes, naming ionic compounds. After today's notes, you should be able to apply the rules for naming binary ionic compounds. Remember, binary means two. So anything that has two capital letters, NaCl, the N and the A are capital, so this is a binary compound. Binary just means two. You should be able to learn the names and charges of our comic polyatomic ions, which we touched base on in the lesson before. And then you should be able to name an ionic compound when you're given its formula, and you should be able to write the formula of an ionic compound if I give you its name. So let's take a look at our naming rules. Rule number 1 is specifically for our binary compounds, anything that only has two capital letters or two elements in the formula. So the cation, or the metal, is always named first. The anion, or the nonmetal, is named second. Our cation keeps its name. The anion gets the suffix IDE. So if we look at our example here, NaCl, Na is sodium, so that gets its name first, it's our metal, and then Cl is chlorine, but because it's in a compound, it gets that IDE ending, so this becomes sodium chloride. Okay, and I gave you examples. Chlorine becomes chloride, iodine becomes iodide, or oxygen becomes oxide. So if we look at a second example, MgO, if we wanted to name this one, we're going to name the metal first. Mg is magnesium. O is oxygen, but because it's in a compound, it's no longer by itself, it's going to become oxide, IDE ending. Okay? If I give you the name and you try to determine the formula, that's the second bullet down here, formula from name. If we wanted to do calcium sulfide and we want to determine the formula. We know this compound is going to contain calcium, Ca, and sulfide is most likely going to be sulfur. We can drop the IDE ending and find what the most likely element is. So sulfide is likely going to be sulfur. Now we have to find our charges. So this is the hard part. When you're determining the formula, you have to look at the charges on the ions. Calcium is in group 2 on our periodic table, so it's going to have a +2 charge. Sulfur is in group 16 on our periodic table. That means it needs to gain 2 electrons to get to its full octet. It's going to have a -2 charge. So then we do our crisscross, +2 and -2. We should be Ca2S2, but remember your formula always has to be the lowest whole number ratio, so those 2's are going to cancel out and it's going to be CaS is our formula for calcium sulfide. I'll do it again for aluminum bromide. Aluminum bromide. Aluminum is symbol Al. And bromide, we're going to drop that IDE ending, is most likely going to be the element bromine. So we go to our periodic table, we find our charges. Aluminum has a +3 charge, and bromine is in group 17, it has a -1 charge. So when we do our crisscross, we're going to drop the charges. The 3 from the aluminum is going to come hang out with the bromine. The 1 is going to crisscross. So we end up with Al1Br3. And just like in math, if you have a 1, you don't have to show it. So our formula is AlBr3. Okay, so those are binary compounds. They're never going to have more than 2 elements. And remember, we can do elements by counting our capital letters if you don't have the elements memorized yet. Okay, let's look at what we call polyatomic ions. So rule 2, rules for naming polyatomic ions. Poly instead of binary. Poly means multi, atomic means atom. So polyatomic ions are ions, things with a charge, that have more than one atom. So if you look at our list, every single one of these, NH4 and an H that's 2 atoms, that's more than one. Carbon, hydrogen, oxygen, C2H3O2, all of those atom elements together make the acetate ion. NO2 is nitrite, NO3 is nitrate. So these are the names for those ions. Just like magnesium is Mg, SO3 is sulfite. So this is something, normally I don't believe in memorization, but I'm telling you right now, if you memorize this chart, your life is going to be so much easier moving forward in chemistry. Normally I think it's ridiculous to have to memorize something if you can just look it up, but this is one of those things where memorization is going to be super, super helpful for you, and it's going to help you be successful. So whenever you're naming binary compounds like we just did, you're going to use your periodic table to find the elements. Whenever you have polyatomic ions, you're going to use this chart. And you can tell that you have a binary because you have 2 capital letters. Whenever you have a polyatomic, you're going to have 3 or more capital letters. Okay, so the use of capital versus lowercase lettering is super important because every element starts with a capital letter. So let's do some practice with these polyatomics. So very similar to our binary compounds, your cation or your metal is named first, and then your polyatomic anion or your nonmetal is named second. Okay, the only exception to this part of this rule is ammonium, NH4+. Ammonium is the only polyatomic cation, so it's going to be named first. So, for example, if you have ammonium nitride, ammonium is NH4, so it says its name, and then nitride, IDE ending, is nitrogen. So you have NH4 first, and then the nitrogen N. And the reason ammonium nitride is NH4 is a +1 charge. We know that from our chart. Nitrogen is a -3 charge. We know this from the periodic table because it's in group 15, which means it needs to gain 3 electrons. Gaining 3 electrons is going to give it a -3 charge. So when we do our crisscross, we need 4 ammonium ions. 3 ammonium ions to donate the electrons to the 1 nitrogen atom. Okay, so the formula for ammonium nitride is NH4,3N. And we need those parentheses there to tell us that we have 3 of the ammonium ion. Okay, let's try another one. So if we want to do, you'll notice that your polyatomics, they always have ITE or ATE ending, with the exception of hydroxide. OH- is hydroxide. It is the only polyatomic ion with an IDE ending. Every other polyatomic ends in ITE or ATE. So if you see these endings, ITE or ATE, in a name, you know to look at your polyatomic ion chart. Okay? I'm going to call it the PA chart. PAI, polyatomic ion chart. So whenever you see those endings in a chemical name, look at your polyatomic ion chart. If you see IDE, you can usually look at your binary at your periodic table. All right, so let's do, if you go from name from the formula, so we have Na3PO4. 3PO4. We have 1, 2, 3 capital letters, which tells us we're going to look at our polyatomic ions. Na is sodium. So sodium is the metal. It's going to say its name. And then PO4 is our polyatomic. If we go to our chart, we look at PO4. is phosphate. So this would be sodium phosphate with the ATE ending. If we do another example, let's name this one here, MgSO3. Capital M, capital S, capital O. So we're looking at our polyatomic ion. Mg is magnesium. And SO3 must be a polyatomic. If we look at our chart, SO3 is sulfite. So the name of MgSO3 as a compound is magnesium sulfite. If we go formula from the name, try and find the formula based on the name. If we look at calcium sulfate, calcium is Ca. Sulfate, ATE ending, means it must be on the polyatomic ion chart. So we go to our polyatomic ion chart and we find that sulfate is SO4 with a -2 charge. Calcium, from our periodic table, is in group 2, so it has a +2 charge. When we do our crisscross, we're going to get CaSO4 because the +2 and the -2 are going to cancel out. So calcium sulfate has a formula of CaSO4. Try the 6.5 activity. It's going to be naming. It's going to be combination of binary compounds and polyatomic compounds. I think you can do it. Let me know if you have questions.